Hello guys, it's Lottie here from Pinpoint Tutoring, and we're kind of starting just a couple of things to help you get back into understanding algebra. Just some stuff you forgot, maybe it's some stuff that you're going to see coming up, but you've probably heard about factoring polynomials before. So polynomials are 2-degree unknowns, right? So you have x squared in there somewhere. If you have an x squared and an x, it's still a polynomial. You identify it by the higher power. If it had a 3, then it would be a cubic, and we'll get to factorizing those later. And if it's a square at most, as you can see in all 3 of these examples, it is going to be called a polynomial. Now these will typically end being broken off into an x plus or minus something multiplied by another x plus or minus something. Because if you recall, just let me check and see that the camera keeps this, yes. You FOIL these out, and that's how you get polynomials. So what you're being asked to do when you're asked to factor polynomials is to factor them back into the original linear factors that they started off with. So these kind of have similar numbers in there. There's a plus 30, and a plus 30 at the end of each one of these. And even though they look special, they're kind of similar in the case that they are all related in a certain way. And I'll get to that whenever I start explaining how to break each one of these down. So a good technique for figuring this out is to first multiply these two terms, your first term and your last term together, including the sign. So x squared, 1x squared to be specific, right? Because if you don't see a number in there, that implies that there's a 1. And then a positive 30. So these two multiply to give you a 30x squared, positive 30x squared. And then to factor these, you have to ask yourself a question. What factors multiply together to give me 30x squared, but add together to give me positive 11x? And that's where the technique kind of branches in a little bit further. So I'm thinking about, first of all, just besides the x squared, what two numbers multiply to give me 30, but add to give me 11? And immediately it should become 5 and 6. Really specifically 5x and 6x. So let's just check. 5x plus 6x is indeed 11x. And then 5x times 6x is indeed 30x squared, because you have two x's multiplying. So now I'm going to rewrite this polynomial using these two terms. And it's a simple breakdown. Since 5x and 6x makes 11x, I can rewrite this whole expression as x squared plus 5x plus 6x plus 30. And this is the first step of factoring. Now, the easiest way to do this is to just figure out how can I factor out of these two and then factor out of these two. So I'll kind of cut to the chase for this example. You have x squared plus 5x. The common factor in x squared and 5x is x, right? So if you factor out an x, you're left with an x in here, because when you FOIL it back in, you'll have x times x, which is x squared, plus, and if you factor an x out of 5x, since the 5 is really multiplying the x, you're just left with the 5 in here. The second part is where you have to be a little bit careful. If you have plus 6x and plus 30x, or sorry, plus 6x and just plus 30, the common factor in both of those, sign included, in this case, and it'll change in the other two, is a positive 6. You think about that, 6 goes into 6x, x times, right? Because when you fold it back in, you'll have 6 times x, which is 6x, plus, and 6 goes into 35 times. Now, if you have done this technique correctly, these two terms that are left behind after you factored should be the exact same. And this is because this is the step that you're really doing in the FOIL process. So if you think about that, when you FOIL, you go first times both two terms, and then the second term times both of these two terms. So this expression is really simplified as I'm going to take these two together and just group them as 1, so x plus 5. And then the terms that were on the outside of each one multiplying x plus 6 become your other factor. So we have x plus 6. And that is how you that is how you factor a polynomial like this. So keep an eye out for the next two examples where sign changes become an issue, and I'll explain that later.